The big question in the end of the 19th century was if light propagates as undulations in a universal medium. This hypothetical medium was called the ether, and with its existence the velocity of light should be different depending on the velocity of the inertial system. The experiment to cast light upon this issue was the Michelson-Morley experiment from 1887. Here we have two inertial systems. We have one inertial system resting in the ether, and the other inertial system is moving with the Earth and with the experiment. That means that we should have an ether wind of the size of the ether wind with the velocity of v. We have a light source sending a light to a half-silvered mirror P. We split the light ray into two parts. One is reflected on the mirror S2 down through the mirror P to the detector, and the other to the other mirror S1 and back, reflected down to the detector again. By measuring these time differences, we can calculate the velocity of the ether wind if we have an ether. We do this and see what happens. We call the time it takes to go this distance and back for T1. T1 will then be equal to L1 divided by the velocity of light in the inertial system of the ether minus v, the velocity of the ether wind, plus L1 divided by c plus v. From this we get T1 equal to 2 L1 divided by c times 1 minus v2 c2. Then we calculate the time it takes to go from P to mirror S2 and back. We call this T2, and it's easier to calculate this by using the system of the ether. And here the light ray will create a triangle with a height of L2. The base will be VT2, so half the base will be VT2 divided by 2. The hypotenuse will be CT2 divided by 2. And by using the theorem of Pythagoras, we get CT2 divided by 2 squared equal to L2 squared plus VT2 divided by 2 squared. From this we get T2 equal to 2 L2 divided by C square root of 1 minus V2 divided by C2. Then we calculate delta T, which is equal to T1 minus T2. We rotate the whole system 90 degrees clockwise and do the same again. But these new measurements we call prime instead. We get T1 prime, where L1 is pointing downwards after rotation, 2L1 divided by C square root of 1 minus V2 C2 T2 prime equal to 2 L2 pointing in the direction of the moment of the Earth, C 1 minus V2 divided by C2. Here we can also calculate delta T prime is equal to T1 prime minus delta T2 prime. We can calculate then delta T minus delta t prime. And it's even better to calculate delta t prime minus delta t. And in doing so we get this approximately equal to 1 over c times L1 minus L plus L2 times V2 divided by C2. This can be seen if we take all these terms and then use Taylor expansion. The measurements showed, the experiment showed that the velocity of the ether wind was at least less than 5 times 10 to 3 meter per second, which is much less than the velocity of the Earth around the Sun, and this is equal to 30 times 10 exposed to 3 meter per second. Other experiments have shown that the velocity of the ether wind is even smaller, and this shows that we have no ether wind at all, and we have no motion through the ether, and the speed of light in free space is the same everywhere, regardless of any motion of the source of the observer. So this means no ether wind